Hi, this is 2016 AP Calculus AB exam question number 5. It's a non-calculator question. What we have here is a funnel that you see in the picture. We do have the equation for the radius, for the outer radius of the funnel that's given to us by this expression, and the height is given to us 10 inches. And the units of R and H are also inches. So we have several questions here. The first one is to find the average value of the radius. To remind you, to find the average value of the function, there is a formula for that, which we're going to use here. And the formula is, in this case, it will be the average value is going to be 1 divided by the interval on which we're trying to find it. It's from the interval from 0 to 10. So 10 minus 0 times the integral from 0 to 10 of the radius function, which was 1/20th times 3 plus h squared dh. Pretty straightforward question here. So this is 1/10, this is 1/20th. This 1/20th can be taken outside, so we can get 1 over 200 times the integral from 0 to 10 of 3 plus h squared dh. It's a very simple function to integrate. You can easily do it. 1 over 200 times, what do we have here? 3h plus h cubed over 3 times, that means from 0 to 10. Let's substitute that. So we're going to have 1 over 200. 0 will give us 0, we don't have to worry about this. This is going to be 300 plus 1000 divided by 3. That would be an acceptable format, but if you actually are going to do the math, oh, let me write minus 0, just so we remember. But if you actually simplify this, this is going to be 109 over 16. Okay. We don't have to show the units here, but the units will be inches since it's the radius, the average value of the radius. Okay. Find the volume. It's a solid thing, so we're going to use a disk method. It has a vertical axis. It's not really going to matter that much here. So to find the volume, is going to be its volume of revolution, ignore that, pi times the integral of the radius squared. So we're going to go from 0 to 10. The radius here is given to us as 1/20th times 3 plus h squared. We need to remember to square that, dh. This will give us 1 over 400. We can factor it out, so it's pi over 400 times the integral from 0 to 10 of 9 plus 6h squared plus h to the 4th dh. It's a polynomial function, easy to integrate. So it's pi over 400. We're going to get here 9h plus 2h cubed plus h to the 5th over 5. From 0 to 10, correct? Substituting 10 and then substituting 0 gives pi over 400. Here we're going to get 90 plus 2000 plus 10 to the 5th is going to be a million, right? Over 5 minus 0. Because we still need to substitute 0 in there, and the whole thing will simplify to 2209 pi over 40. This will be cubic inches. It is not asking for the unit again, but just in case if we need the units, that's what it's going to be. So it's a relatively simple problem actually. A and B are both pretty straightforward. Part C. Let's see what the question is asking us. So we have the funnel that contains liquid. that's draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius is decreasing at a certain rate. So what we need to do is we need to determine the warp rate of change of the height with respect to time at that instant. Okay, so we know how R and H are related to each other. You actually already have an equation given to you, you don't have to come up with one. So when you take that, which is R is equal to 1/23 plus H squared. When you take the derivative on both sides, dr here is going to be 1/20 times 2h times dr over dt with respect to time, dh over dt, correct? So we have this information given to us. So what do we have here? We have a height of 3. We know that the radius dr over dt, which is 1/5, that's given to us. Let me show you this. So this is our, the radius is decreasing, so it's negative. So we need to make ourselves a note here. It's negative 1/5. We know that the radius is going to be, the height will be 3 inches, right? And we put it all in. So it's negative 1/5 equals, that's 1/10 times 3 times dh over dt. Right. And the rest is a pretty simple work. And dh over dt from here is going to equal negative 2/3 inches per second. Okay, so like I said, this whole question is actually pretty basic. You do have a bit of a strange shape, you may think at first, and you don't really have an axis around which you rotate, but you know, it's still not a hard problem to do at all. It does have 3 concepts that are normally tested, which is the average value, volume, and the related rates. Those are parts A, B, and C respectively. I hope this helps.